Hello, in this video today, I will walk you through how to create a seamless NFT experience for NFT shoppers to kickstart your e-commerce business. So by the end of this video today, we will have learned 3 things. We will create an ERC 1155 edition contract. We will create a Stripe account as well to accept payments and set up an endpoint for deploying our application. And last but not least, we will create a full stack Next.js application with Stripe payment options embedded. Now, without further ado, let's get started. We will first need to head to the Third Web Explorer page and locate the ERC 1155 edition contract and click on Deploy. Here, let's make sure that we're on the latest version of the contract and then click on Deploy Now. This will pop up a drawer for us to set up our smart contract with an image, name, description, etc. And for this one, I will be deploying a contract with the Pixel Heart collection. And then we can configure which wallet address will receive the funds from the primary and the secondary cells. And for this video today, we will be deploying the contract on the Polygon Mumbai test network. After we click on Deploy Now, this will prompt 2 steps for us to deploy the contract to the Third Web dashboard. The first step will prompt our wallet for us to sign the transaction, and the second step is adding the contract to the dashboard, which will not cost us any gas fees. And now that we have deployed the contract, let's go to the NFT tab and click on Mint. This will open another drawer for us to add some metadata for our NFT. And let's give it a cool name and a media image. And then we'll set our initial supply of the NFT, and I'll be setting it to 100, just as an example. And once we have finished with the metadata, click on Mint NFT and approve the transaction. And now we need to head over to Stripe to get the API keys, and we need to first create an account if we don't already own one. And once the account is set up, we will see our API keys here on the dashboard. And let's keep our tab open for this one, as we'll need to come back to them to paste them in our env variable file to deploy our application on the blockchain. Now let's go to Magic Link and create an account as well. Magic Link is an instant Web3 wallet for developers to integrate into their Web3 application. Once an account is created on Magic, we want to create a Magic authentication app that allows for custom wallets and authentication. And be careful here not to choose Magic Connect, which will create a global wallet for us. We'll be using the Magic API keys in our application as well, so let's also keep this tab open. And now we're ready to create our full stack Next.js application with our Web3 functionalities. So in our terminal here, let's type in this command to create a new project using TypeScript and the Third Web SDK. We will call this project Seamless NFT Experience, and we're using EVM for this project. And let's give it a few seconds for the packages to install. And once the installation is complete, let's head over to VS Code or whichever code editor you prefer to use and open up our project. In the _app.tsx file, change the active chain variable to Mumbai because we deployed our contract on the Polygon Mumbai test network. And next, we will add an env.local file to include all of our public and private keys, but make sure this file is added in git ignore. Otherwise, it will push all of your private keys and public keys to GitHub, and this can potentially put your wallet at risk of being drained. The best practice here is to use a secret manager to store your private keys, But since we're using the test network here, so it is not a big concern at the moment. But if you were to deploy your application to production, it is still recommended that you use something like a password manager. Now let's switch over to the underscore app.tsx file again and paste in this code here underneath the chain ID variable. This code is essentially setting up a wallet connector for our decentralized application that will be using the Magic Link API to connect to the Mumbai test network. So in simple terms, a wallet connector is a tool that allows a dApp to interact with a user's crypto wallet in order to send or receive digital assets. And the Magic connector here is a specific wallet connector that will be used in our dApp. And this options object passed to the Magic connector constructor contains the API key that's needed to connect to the Magic Link service. And the RPC URLs property is used to specify the URL of the blockchain node that our application will be connecting to. And the connectors array is an array of the wallet connectors that we'll be using in our application. And in this case, there is only one connector, which is the Magic Link connector that was created earlier. And in our third web provider component here, let's add a wallet connector property, which specifies an array of wallet connectors that our application will use to connect to our wallet. And this array is going to contain the Magic Link connector that we defined earlier. And this last piece here, the component page prop syntax at the end of the code simply renders the main component of our application and passes any props to it. The third web provider component wraps this component and provides the necessary blockchain connection and wallet connectivity to it. Now in our index.tsx file, let's remove the original content that came with a template within the return statement. And let's add in the sign in with email that we need to take the email from the user and connect with Magic Authentication using this piece of code here. And above the return statement, we'll also include these hooks in our file and import them from the Third Web SDK. Let me break it down for you a little bit. These hooks are used to add functionality to our application using the useMagic and useAddress hooks from the Third Web SDK. The useMagic hook is being used to create a function called Connect with Magic that will handle the user's login process. And this function can be called to connect the user's wallet using the Magic Link service to authenticate the user's email address. And the useState hook here is being used to create a state variable called email and a setter function called setEmail. These are used to manage the user's email address input on the login form. And the useAddress hook here is being used to retrieve the user's wallet address once they're logged in. This address can be then used to interact with the blockchain and execute transactions on behalf of the user. And this piece of code here is essentially rendering a simple form that allows the user to log into the application using their email address. And when the user submits the form, the Connect with Magic function will be called with the user's email as a parameter. And the form consists of an input field where the user can enter their email address and a login button to submit the form. And the rest of the code here is some styling of the form, which you're totally welcome to customize on your own. Now back in our index.tsx file again, we will need to make an API request on the front end to get and store the client secret in a state like this. Here the code is setting up a state variable called client secret using the useState hook. And then it uses the useEffect hook to perform a post request to a serverless function called API stripe intent, passing it an address variable in the request body. And once the response comes back, it sets the client secret state variable to the value of client secret field in the response. And this piece of code here essentially sets up a state variable called client secret using the useState hook. It then uses the useEffect hook to perform a post request to a serverless function called API stripe intent, passing it an address variable in the request body. And once the response comes back, it sets the client secret state variable to the value of the client secret field in the response. Next, below the "you are signed in" message, let's add the following code. This piece of code here is rendering an NFT media file along with its name, description, and price inside a div element. And the third web NFT media component here is being used to display the NFT image. And this metadata property is set to NFT metadata, and this is used to retrieve the NFT's metadata information. And the NFT metadata name and NFT metadata description are essentially displaying the name and description of the NFT respectively. And the price of the NFT is hard-coded to $100. And if the NFT object is not available or its metadata property is empty, none of the NFT information will be displayed. Next up, we'll be setting up the APIs to get the payments, so we'll need to install the Stripe packages in our terminal like this. Once the packages are installed, we will need to create the API by making a new file called stripe_intent.ts in a new folder in the pages folder. So let's create a folder called API in the pages folder and add this chunk of code into our file, and I'll break it down one by one for you. Essentially, this code is defining an API route function that creates a new payment intent using the Stripe API. The function essentially takes a Next API request and a Next API response object as arguments and extracts the address property from the rec.body object. And the amount will be in subdivision of a currency, so for USD, it will be in cents. To get what we need to simply multiply the USD amount by 100. So a new payment intent is then created with a fixed amount of 100. So in order to create a payment intent of a fixed amount of $100, we'll need to enter 10,000 here. The description property is set to payment description, and the metadata property is then set to include the address property. And here we're saying that if the payment intent is created successfully, a JSON response with the intent objects is sent with a status code of 200. And if there's an error during the process, a JSON response with an error message is sent with a status code of 500. Now back in our index.tsx file again, we will need to make an API request on the front end to get and store the client secret in a state like this. And this piece of code here essentially sets up a state variable called client secret using the useState hook. It then uses the useEffect hook to perform a post request to our serverless function called API Stripe intent, passing it an address variable in the request body. And once the response comes back, it sets the client secret state variable to the value of the client secret field in the response. Now we also need to show the card elements where people will enter their card details. So for that, let's prepare our options that Stripe needs and import the necessary modules for that. This load Stripe function is called with the Stripe publishable key to create a Stripe object, which can be used to interact with the Stripe API. And so this object appearance is created with the theme property set to night and labels set to above. And in another object, options is created with the client secret property set to the value of the client secret state variable and appearance set to the appearance object created earlier. And just before the NFT card, I will also display the form inside a Stripe element wrapper like this. And this essentially renders a component called form wrapped inside an elements component from the Stripe API. And this only works if the client secret state has been set. So you may be wondering where the form component came from. We will essentially need to create this form component by creating a new components folder and a new file called form.tsx inside the folder. And we'll add this chunk of code in this file. This piece of code essentially adds payment elements where users can input their details and a payment button. It defines the form component, which includes a payment form with a Pay Now button that confirms a Stripe payment when it is clicked. It also uses the Use Stripe and Use Elements hooks from the Stripe library to access the Stripe instance and create a payment element, so that when the button is clicked, the handle submit function is called, which uses the Stripe confirm payment method to send the payment information to Stripe for processing. And finally, the isLoading state variable is used to disable the Pay Now button while the payment is being processed. Now that we can accept payments from Stripe, we will need to add a webhook to send the NFTs and get updates from Stripe as well. And to create a webhook, we'll need to create a webhook.ts file in the Pages API folder. And let's add this chunk of code in our file. This essentially defines the Stripe API route handler for a webhook endpoint that listens for the payment intent succeeded event sent by Stripe. And when such event is received, it retrieves the customer's address from the payment intent's metadata and mints an ERC1155 token and sends that to the address and logs the information about the successful payment. It also creates an instance of the Stripe class with the Stripe API secret key and sets the API version to use. And it gets the webhook secret from the environment variables. It also configures the API route to not parse the request body and instead use the buffer function to read it. Then it defines the handler function that will be called when the webhook is received. It first reads the request body into a buffer and retrieves the Stripe signature from the request headers. It also creates an instance of the ThirdWeb SDK class and initializes it with the private key and the network to use, and retrieves a contract instance for an ERC1155 token. And then it will construct a Stripe event object from the request body and signature using the Stripe SDK's construct event method. If the event type is payment intent succeeded, then it will retrieve the payment method and address from the event data's object and metadata properties respectively. And lastly, it will mint an additional ERC1155 token and send it to the customer's address using the ThirdWeb SDK's mint additional supply to method. And it will also log information about the successful payment and return a JSON response indicating that the webhook was received. We have now set up our webhook, but we need to get updates on it as well. So for testing our application on the localhost, we'll need to install the Stripe CLI. Once we have installed the Stripe CLI, we need to run Stripe login to log into our account. So now let's run this command to listen to the webhooks in real time. So in order to install the Stripe CLI, we can just do brew install. And after we have installed it, we'll just do Stripe login. And once we're connected to Stripe, we'll run this command here to listen to the webhook in real time. After we run this command, it will show us a signing secret key that we'll be including in our .env local file. So now we can try out the app with a test card. And if you see that nothing happens after we complete the payment, this is normal because we haven't added functionalities to let the users know whether or not the payment was successful or if it has errored out. So we will need to include a message in our form.tsx file. Here, the most important thing is that we're setting up some state variables using the useState hook. The message is set to either null, string, or undefined, and while isSuccess is set to false. We then use the useStripe hook to access the Stripe object, which then return as a result of loading Stripe in the previous step. And we'll set up an effect that runs when Stripe is available. It checks whether a client secret was passed in the query parameters of the URL. And if so, it will retrieve the payment intent from the Stripe using the retrieve payment intent method. And this method returns a promise that resolves with an object that contains the payment intent property. It will then check the status of the payment intent using a switch statement and sets the message and isSuccess state variables accordingly. So if the payment succeeded, isSuccess is set to true and message is set to a success message. If the payment is still processing, the message property is set to a processing message. And if the payment failed, the message property is set to a failure message. And if none of these cases are met, message property is set to a general error message. And in the return statement, we also want to add a component that conditionally renders either a message or a payment form. So now if the user returns, there will be an ID in the URL, which we can check using Stripe and show a message based on that. And here in the href, we need to update this address to the edition contract address that we deployed earlier on the dashboard. And now we're ready to deploy our application and test it out on the local host. But before we do that, we need to go to Stripe and activate the payments and provide some details to activate the account. And once that's complete, we'll go to the developer section and click on the API keys tab. Here, let's grab the production API keys and include it in our env local file. And let's head back to the Magic Link tab and grab our Magic Link API key as well and include it in our env local file. And finally, we need to add a webhook endpoint to Stripe to get the webhook payment intent succeeded event logs. So let's go to the webhooks section under the developers and click on add an endpoint. And then we'll need to add in the following details, which is first, the URL will be the domain that we deployed our application to, which I have used Vercel as an example here. And then you can enter anything here for your description of your project. And make sure we're on the latest version of Stripe, so we want to update it to the November version. And last but not least here, let's select payment intent.succeeded as an event to listen. And once we're done, let's click on add endpoint. And finally, let's test out our application. For simplicity, I'll be using the localhost for a quick demo. And in our terminal, let's run yarn dev to kickstart the localhost. In another terminal, I'll also be starting the webhook to listen to the payment intent success events. So as you can see here, this application will show a login form for the users to enter their email address to authenticate. If you're a first-time user, it will prompt open your wallet to ask you to sign in. And since I've already played around with my website a little bit, so it has remembered me as a user, and that's why it did not prompt open my wallet. And once you're logged in, you will see the NFT details and the image that is currently on sale, and the Stripe payment section to process the transaction. And here I used the Stripe test card to process the transaction, which means that there is no real money being involved in this situation. And for the expiration date and CVC numbers, I just used random numbers and a future date and the year. As we can see here, the payment has successfully completed, and we can also check out this NFT on OpenSea testnet here. And if you want to see the webhook event, we just need to go back to our terminal and click on the link here. And as you can see here, this payment intent succeeded event has been triggered, and it shows this JSON response that includes the payment intent's metadata and logs information about the successful payment of the NFT. And there you have it. You have learned how to create a seamless NFT checkout experience for your users by allowing sign up using Magic Link and accepting credit card payments by using Stripe. And if you liked this tutorial today, please give it a thumbs up and subscribe to our Third Web YouTube channel. And if you have any questions or comments regarding today's video, please leave a comment down below or join our Discord community and speak directly with our Third Web team.